Hi, welcome to my YouTube channel, and I hope you all have came across my first video on the history of artificial intelligence, and you got a brief idea how the AI has evolved from zero to the level you see nowadays. So, in this video, I will announce about two new courses in my channel. So the first one is on Python, and the second one is on the most awaiting or what people like. There are a lot of courses on this topic, but I think they are not compact. Okay, so I'll say why I'm launching. So the second course is on AI on zero to advanced level. So first of all, I come across why do I need a new course for Python? Okay, because there are a lot of videos already on YouTube which you can see and learn Python. But my question is, you have to know why Python. Everybody tell you what is Python. Okay, no problem. But my question, why Python? So mainly we will see Python based on real life application that you can simply open a VS Code and code some product by yourself. Like when I talk with people, they go for thousands of courses, but when they open the VS Code and try to build something, they can't. Okay, so that's my plan, that to bring you at a level in Python that you can open the VS Code and you can build anything. Okay, so first of all, what we are going to cover in Python. So first of all, we'll cover the fundamentals. Okay, I think if you have came across C or any other programming language, you have the idea of fundamentals. So we will not spend a lot of lecture like what is this, what is loops, what is if else, what are the oops. Like we will spend time on oops because it is important, but not on other topics much. We'll spend but not much. Okay, rather we'll focus on real life application, how we can implement them in real life. Okay, so once we are done with the core Python, we will focus on NumPy, we'll focus on Pandas, Matplotlib, Seaborn, Plotty. Okay, so why these libraries? Because as I told before, our next course is AI from the scratch. So if you want to build any kind of AI models, so you have to know Python in very depth. Okay, and before training any model, you need data, and you need to pre-process the data. You need to clean the data. So all these stuffs will be covered in this Python lecture series. So this Python lecture series will be a prerequisite sorry, for our deep learning series, but still we will go simultaneously both series. Okay, so it's not that you first of all I will complete the Python then deep. No, we will go simultaneously. Okay, so just go through both of them and you will understand. Okay, next come the most awaiting, the AI from the scratch. Okay, so the question comes why? Because again, there are a lot of YouTube videos, you can watch simply, but I think there is not a single channel where you can get everything at one place. Okay, and also some people focus on theory, some focus on practical, some focus like on just bring some like TensorFlow as sklearn and implement some products. But again, if you don't learn how to build them from the scratch, you cannot be a good programmer, AI developer, right? So we'll learn how to build all those kind of algorithms or products from or machine learning models from the very scratch. Okay, so we will use sklearn or TensorFlow or PyTorch. Like for deep learning, mainly we'll focus on PyTorch. Okay, but we will learn how to build them from the very scratch. Okay, but for heavy models we will use pre-trained models. Like we will not go for like, we'll just do in our capacity, that's all. Okay, so let's come to the syllabus of AI, how we will proceed. So first of all, we'll start with the basic machine learning, where we'll start from the simple linear regression. So first of all, we'll understand the history, the concept, all kind of like mathematical and geometrical intuition of linear regression, and then we will implement from the scratch. Okay, in Python, and also we'll try to do using like sklearn. It's a Python library. Using this, you can simply implement such ML algorithms. Apart from that, like if you're preparing for GATE exam or if you have data science as your specialization in any kind of university, so they ask you numericals in the exam. Okay, so I don't think there are so many YouTube channels who teach you all. Even I think like if you really want to have good understanding of algorithms, you should solve some like numericals, okay, mathematical. Like in case of real life, you have huge data set, right? So you solve numericals, like this done by computers, right? All the calculations. But I want you should solve some numericals on small data set that you can have an idea how all the calculations are working internally. Okay, so first of all, we'll start from simple linear regression. Second, we'll go for multiple linear regression. And then we'll learn about some metrics, like we just build some regression model. Like again, I'm saying regression classification. If you don't know what is this, I will cover in detail in our deep learning series. Okay, for time being, just know, let's say you give an input, okay, and if the output is any number between 1 to 10, let's say 1.5, 1.55, so it's a continuous range, right? You cannot simply just predict like it would be like yes or no, or like it's a continuous range, right? So these kind of problems we'll see, these are the regression problems. We'll focus in detail. And second is classification models, where the output comes under certain class. Let's say it's a cat and dog, so two class, cat class and dog class, yes or no, like a email is spam or not spam, two classes. Okay, so when we have discrete output, we call it classification algorithms and classification problem, and the algorithm we use called classification algorithms, and second one is regression. Okay, so in regression, first of all, we'll learn simple linear regression, then multiple linear regression, and later we'll learn about the R2 score, cost function and stuff like this to evaluate how good our model is. Because again, we just build a model and we are just building, we don't know how good it is. It does not make sense, right? So it's kind of important. Okay, so in the next step, we'll focus on gradient descent. So gradient descent, you can say, it's a kind of core, like it's a kind of pillar, it's a kind of spirit of deep learning. So this is one of the most vital lecture, because later if you want to learn about deep learning or anything, okay, you have to have mastery over gradient descent, because it's one of the topic I find is one of the most hardest topic in deep like AI. And if you do not have mastery on this topic, then you have to suffer in the future. Okay, so stay tuned for this lecture. Then we will learn about the polynomial regression. So we'll solve those regression problem using gradient descent. So it's a kind of heavy topic. So after that, we will try to improve the performance of our regression models. So we'll study about the ridge regression, lasso regression, elastic net regression. And next come to the classification, means yes or no under certain class, discrete model. So we'll start from the logistic regression. It's again, you can ask me that you said it's classification, then why is called logistic regression? Why not logistic classification, right? So we will discuss everything. I know you have a lot of questions in your mind right now, but we'll answer. Then we'll learn about decision tree, naive Bayes. Again, using those like tree and naive Bayes, you can solve regression as well as classification, both problems. So I will show you how you can solve, and we'll see in deep, okay, everything. So right now, just see. Then support vector machine, then k nearest neighbor. Then again, we have to learn how to evaluate those classification models. We have to learn about the confusion matrix, the precision recall, F1 score, ROC, AUC, etc. So we will see everything. Next, we will learn about the cross validation, overfit, underfit, bias variance trade-off, learning curves. Means, let's say you're building a model. So how good the model is learning, right? Let's say you're teaching a lot, but it's not learning anything. Or maybe it's learning a lot, you're not teaching anything, right? So there could be multiple situations, like just as a student and teacher. Okay, so we'll see all these things in very detail. Okay, and next comes our unsupervised machine learning. Again, before I didn't mention, these all were supervised machine learning algorithms. And next we'll go for some unsupervised learning, like for clustering. So we'll see what these things are. So we'll go for k-means, DB scan, Gaussian mixture models, and hierarchical clustering. Okay, and then we will go for few algorithms where we reduce the dimension of the data. Okay, so for that we'll use PCA, kernel PCA, and etc. like this. Okay, so far this is, and after that we have some ensemble learning. Means let's say there is one model giving you output. What if I make a team, like I put multiple model at a time, okay, and get the output? So they are somehow boost. So these are also called kind of boosting algorithms. So we'll go for like bagging and boosting. Also, we'll go for random forest. We'll go for XGBoost, ADA boost, cat boost, gradient boost, etc. Okay. So once we are done with these kind of machine learning algorithms, we'll jump into deep learning. So in deep learning, we will have first of all basic perceptron, and then we have multi-layer perceptron, activation function, loss function, back propagation. Okay. So these are the basic fundamentals of neural networks, like this topic I told right now. Okay. Uh, of neural networks. So once we are done, we will go for some specific applications of neural network. Let's say image classification. So for that, we'll study about the convolutional neural network. Okay. So in CNN, so we'll study the basic architecture in very detail, and we'll start to build some good models. After that, we will see how we can improve the performance of the CNN. By the way, before I forget to mention, after studying the basic of neural network, we will see how we can improve the performance of our neural networks. Okay, then we will study out the CNN. So based on CNN, there is a new branch of deep learning. It's called computer vision. Okay, so we will focus this part computer vision in very depth. Okay, so let's say there is a cat picture, a dog picture. Okay, so just by using CNN, you can say it's a cat or dog picture. But let's say in a picture, there's a cat, there's a dog in a single picture. Then how the model can classify where the cat exactly is and where the dog exactly is. Okay, so this is kind of depth concept, and we'll study them. So this is a branch of deep learning called computer vision. So there we'll start with the basics of we'll study about some basic pre-trained models. Like you will learn what is pre-trained models, what is transfer learning. Okay, so we'll study LeNet, AlexNet, VG16, ResNet, such models. After that, we'll jump into RCNN, and then fast RCNN, then YOLO SSD, and we'll study, like if you are into a bit deep learning, you must have heard of YOLO, right? So we'll study about the YOLO V1, V3, V5, and V8. Okay. Once we are done with the computer vision, we'll jump into our next session. It's called natural language processing. Okay. So in this session, we'll start with our first neural network architecture called RNN. We'll study RNN in very depth. Once we are done with RNN, we will jump into new, like we'll see some downside of RNN, why it does, we don't use it much. Then we'll jump into our new algorithm LSTM, then bidirectional RNN, then we will go for GRU. Once we are done all of them, we will study about the encoder decoder architecture. Okay, so like we will make a stack of multiple LSTM algorithms. Okay, once we are done all of this, we will jump into the most awaiting series called Transformers. So in Transformers, like it came in 2017 by Google, and it's one of the most evolution in the human history. You know, it's so we'll study in very depth. Okay, so in Transformer, we'll study about the word embeddings, self-attention architecture, etc., etc. But we will not only stay into Transformers. We will study about the architecture of a lot of AI like GB2, DeepSeek, Mistral, you know, and how they kind of manipulated this self-attention architecture. For example, in case of DeepSeek, they kind of did some manipulation in self-attention, and they brought multi-head related attention. Okay. So after that, once we are done with Transformer, we'll divide this transformer into two parts. First of all, pre-training, fine-tuning. Again, this pre-training and fine-tuning will be also in computer vision. Okay, like first of all, every ML, while you train a model, it has two parts: pre-training and fine-tuning. Okay, so we'll see in computer vision as well as NLP. First of all, pre-training, second fine-tuning. Okay, so we will see how we can find a lot of like LLMs. Like we'll try to fine tune Mistral. We'll try to fine tune Gemma, like Google Gemini, you know, and that's all. Okay. After that, let's see what we can do. Okay. First of all, let us proceed. So I am planning this course gonna be kind of like 6 to 7 months. I'm not sure, but again, if you wanna learn in very depth, so it takes times. Okay, so first of all, in every week I will try to post at least 4 lectures, each on two on Python, two on deep learning. If we are done with like Python, then in 1 week I will post full lectures on deep learning or AI. Okay, so that is our plan. So thank you, keep supporting me and keep learning, keep watching, and let's make India a great country where people can learn AI freely and easily. Okay, so bye bye, take care.